Welcome to the introduction to limits. Limits are usually covered in pre-calculus somewhere and then also usually expanded upon in calculus. And I like to start a calculus course just going over limits because it's so fundamental to what we do in calculus. So if you've never seen a limit before or you want to get a better understanding, this is the place to start. Okay, so we have this picture I've drawn, and it's just a guy, and over here I've drawn basically a big blue wall, and a line from the two, and these numbers, tick marks, are just distance markers. So you can think of this as 10 feet, 20 feet, or 10 meters, 20 meters. So if he were to start here where he is and walk this way, he'd be walking 10 meters, 20 meters, so on and so forth. Okay. So let's do that. Let's imagine that he does start there, and that he's walking this way towards this wall, and he ends up over here. So he ends up over here, and in the process he shrunk significantly. I don't know, I don't know how that happened, but so he ends up over there, and let's say we measure his distance, and it's 79 meters. Okay. Well, let's say he wants to get closer to the wall for some reason. He's 1 meter away, but he wants to keep walking. So he gets closer to the wall, and let's say that we measure his distance again, and it's 79.9 meters. So now he's only 0.1 meter away from the wall. Okay. Well, let's say that's not good enough for him. Let's say he wants to get even closer to that wall. So he moves closer, and let's say now he's at 79.999 meters. So he's really, really close to that wall. Now let me ask you a question. Will his distance ever actually be 80? Will the distance he travels ever be 80? And the answer is no, because there's a wall there. He can't. The wall is at 80, so he can't actually be at 80 unless he did something like stand on top of it or something. Then he would be at 80 meters. But until that point, he's always going to be a little bit less than 80 because the wall is there. Okay, so just keep that in mind. Okay, well let's say he wants to get even closer, and he's really good at getting close to things and knowing exactly how close he's getting, and he goes and he gets closer, and let's say he's at 79.999999999 meters. And let's say he gets even, let's say that's a few atoms away from the wall, so he's really, really close. Well, what number is his distance approaching? As he gets closer to the wall, what does his distance get closer to? What number does his distance get closer to? And you can see that we started at 79, we went to 79.9, and so on and so forth. These numbers are getting closer to 80. 79 is only 1 meter away from 80. 79.9 is only 0.1 meters away from 80. So on and so forth. This number here is really, really, really close to 80. All you need to do is add a 0.000000001, and you'd be at 80. And as he got closer to the wall, that happened. He got closer to 80. So the way we write that is we say the limit, and we just abbreviate it LIM. The limit of this guy approaching the wall. So in other words, the limit as this guy gets closer to the wall, so this guy's getting closer to the wall, and the limit as he gets closer to the wall, and then we have to decide what we're talking about, what limit we're talking about. And what I mean by that is, in our case, what we're measuring is distance. So the limit as he gets closer to the wall of the distance. So we're saying this guy's getting closer to the wall. When that happens, what happens to his distance? And his distance gets closer and closer to what? Well, we already said it. It gets closer and closer to 80. And I guess in this case we have units, so it could be 80 meters. So that's what a limit is. We basically we pick something that's getting approaching something else. So in other words, in this case we had a guy approaching a wall. Usually we're going to end up with a variable approaching a number, but for right now we had a guy approaching a wall, getting closer and closer to a wall, and then we say if this guy is getting closer and closer and closer to this wall, what is the distance getting closer and closer and closer to? And when you can answer that question, that's the answer to your limit. That's what a limit is, essentially. So let me just reiterate that one more time. Is as this guy gets closer and closer to the wall, what does the distance get closer and closer to? And you can see just from looking at these numbers over here, the distance is getting closer and closer to 80. And the interesting thing about all of this, the reason we even have limits is because his actual distance, let me write this up here, I guess. His distance can never actually equal 80. His distance can't ever equal 80 because there's a wall there. We already talked about that. But the limit of the distance, and if you wanted to write it out, the limit as this guy approaches the wall of the distance. So the limit of the distance does equal 80. And the fact that there's that discrepancy, that the distance will never be 80, but the limit does equal 80, is really what helps us out is really what we're going to be using in calculus to deal with some things that are almost conundrums, if you think about them. Okay, so those are limits, or that's an introduction to limits. In the next video, it will be the follow-up to this, where we're going to talk about things in a more mathematical sense, where we're going to start using variables and equations and things. Okay, see you then.